Hello, everybody! This is Spaghetti Coconut, and RR2 just released on Steam. So, I'm gonna do a massive, big-ass tutorial on everything you need to know about this game. This game has a very steep learning curve. It took me a very long time to master it, and there's still some things that I haven't mastered, but I know it well enough to help get you around the game. So, we're going to start off with the workshop and getting the stock bots in. So as you can see, I already have all my robots in here. These are mine. These are not the robots that come with the game. So these are all the stock robots. So to get these into the game, so let's go back to the main menu. So you go into workshop, like I just did. Then you go down to the import key, and then you go and click on one of these, and then you press the import key. And just like that, the robot is now available for you to play with. Like I said, none of these are going to be in it, because these are just my personal robots. But in the import folder, you can find Cheezus, Deuteranopia, Honk, Jagged, and Launch Control. All of these robots are made by our devs. They're all really cool. They all work in the game. You can go and you can tamper with them and look around inside and see how they work. They're super cool. I encourage you to do that when you're learning the game. But speaking of learning the game, let's take actually, before we leave this screen, let's take a look at the other keys here. So, the new robot key is to create, of course, what it sounds like, a new robot. It starts a new template for you to start building off of. The edit robot key is when you click on a robot file, and you can hover over edit and click on that, and be sent into the bot lab so you can tamper with that. The scrap robot key is if you no longer want a robot. You can click that and it gets rid of it from your inventory. The export key is if you want to move it to your user robots folder, which is where all the stock robots are. Like so. Like, I'll export this one, and if I go to the import folder, it is now in here with the others. And you can open the user robots folder by clicking that button, and it'll take you there if you want to go get the files and send them to people and stuff. It's really cool. Alright, so now let's get into the bot lab. This is going to be the meat of the game. So this is the bot lab, and this is where you create brand new robots. So to start, you just press let's build. And you can move the camera around by holding right click and panning with your mouse, like I'm doing right now. And you can pan under, you can pan above, pan all around. And if you want to zoom it, you can also do this with the middle mouse. You can zoom in and out with the scroll wheel. You can hold shift and pan if you want to. All of these are viable options to move the camera. Personally, I do right click because I find it the easiest. So let's get into the basics of robot building. I'm going to call this Basic Robot 1. And to name a robot, you just click up here on the name bar. There's some little informational tabs. This is just basic tutorial aspects. These are the hotkeys, if you want to learn them. These are information. This is information for welding, which we will get into later. But first, let's create a new chassis. So to start off, we're gonna go into this little grid here, and we're gonna move our mouse over to this little node right here, and we're gonna click, and you see it turns red, and then we're gonna drag our mouse out, and you can see that it's creating this line here. So we're gonna click again on this node now, and now that anchors it, and it creates this solid line here. But now I have another line I need to make. So I can move over here. Place it down right there. And do the same thing down. And do the same thing across. And you see, as I complete the shape, it shows up on the workbench that you have. Right now, it's just a two-dimensional flat plane, but we can change that. So by adding another layer, it is now a 3D rectangle, or a rectangular prism here, yeah. And you can adjust its height. And if you don't like the shape, you can discard it with the X key. You can reset it with the little button there. Or if you're happy with how everything turns out, like I am here, because we will use this as our base plate, you can click the check mark. Alright, so now we have our base plate, or the beginnings of our base plate. If there's something that isn't right, you can just go back with that little arrow key that I just clicked on. But if you're good to go, you take your mouse and you click on you click on one of these little options down here, and they will generate the collision for your base plate. This will as the collisions go up, they become more complex. This really isn't too terribly important for your base chassis, but it is important for something I will get into later with custom shapes. But at first, we have our base plate. So right now, our base plate is made out of blueprint material. And we don't want that, because blueprint material, it doesn't function as armor, it's just a base material. So you're going to want to click on your base plate, and you can see where your mouse is with this little green bubble that's following me around. And then you're going to go click on the Materials tab. You're going to go down this little sub-menu here, and make sure you click on your chassis again. Go down your little sub-menu here, and you can select any of these to make your chassis out of. I would recommend making it out of a metal, like mild steel. So once I click mild steel, you can see that the other sides aren't yet mild steel. We can fix that by clicking the Set for All Sides button. And now every single panel on your base plate is now mild steel. All of these different materials, by the way, have different weight properties, different durability properties. They're very interesting to play around with. I will get in depth with that later, along with this little thickness slider down here. But for now, let's just make a base plate out of mild steel, set for all sides, and let's change the color. So if you click the tint button, you can choose any of the preset colors, or you can adjust the sliders to make your own color. Like this kind of orangish color that I just made. And if you want to apply this to the rest of your base plate, you just hit Set for All Sides again, and now the entire base plate is orange. It's easy as that. Alright, let's talk about mounting things to your base plate, because right now we just have really nothing. We have a metal plate. So what you're going to want to do first is you're going to want to put some drive on the robot so it can move. So for that, you're going to click on the Motion tab, and you can either go to Motors or Brushless Motors. There's a lot of variety from what you can choose from, a lot of different sizes for different weight classes. But for now, we're going to be using a very, very basic motor, the Ampflow A28400. It's a very reliable drive motor. It's very torquey. It can be geared to be very fast. I use it a lot. A lot of beginner users use it a lot. It's a great starter motor to use. So you can click the little Ampflow button down here and drag it out with your mouse. You don't have to hold it, but once so here, let me show you. So once you click this button, you can just move your mouse out here. Instead of the little green bubble I mentioned earlier following, it'll be the amp flow, or whatever component you've chosen. So to place it, you click your mouse again, and it sets it down. So, as you can see, we have our motor on our base plate. So if you click on the motor, you can move it around with these directional arrows. You can move it up, down, front to back, sideways, whatever you need to do. And if you look at this little side menu here, you can click on the R key, or this little R button here. And you can use these little axes tools to rotate the motor any direction you want. So it's not just sticking vertically, like so. And if you want to get rid of that, you can hit the delete key on your keyboard, or you can click this little X button in the corner. I personally just find hitting the delete button to be quicker. And if you want to really get rid of it, just click yes. Alright, so let's create a drive system using AmpFlow A28400s. So this little sidebar is going to come in very handy for what I'm about to do. So you're going to open it up, and you're going to go down in the mirror, to the mirror option, and you're going to check it. This allows you to place two motors at once on opposite sides of an axis, or a mirror plane, which right now mine is set to X. So these motors will mirror horizontally across from each other. So I'm going to place them down. We're going to take the motors, rotate them with the rotation tool a little bit further. And we're going to move the motors up like so. And then we're going to move them apart a little bit so they're placed down like that. And then we're going to move them towards the center of the robot. And we are going to place a transmission on it. So a vital part of drive systems is the transmissions. You can't just take a motor and slap a wheel on it and expect it to work. That'll enter all kinds of different consequences with your motors burning and not having enough power and whatever. It gets really in depth, but again, we'll get into that later. Right now, I want to focus on just adding the transmissions. So once the motors are placed down, you can go grab one of these gearboxes. The most commonly used gearbox to complement this motor is the gearbox medium. So you're going to click on the gearbox medium, and you're going to hover over the axle that is on the amp flow. And you're going to pan your mouse to kind of move it in onto that axle, and you're going to click. And with that, your transmission is now placed. Now you can go about adding your wheels. So to add the wheels, you're going to go to this little weapons tab here. Or really wheels. Well, wheels tab if you want the stock wheels. But I'm going to get into why these are not preferable. But first we're going to go to the weapons tab because there is a very vital step that you need to complete before adding a wheel directly onto the gearbox. So if you click the weapons tab, and you go to shapes, and then you go to cylinder, and you're going to move it over the little gearbox nub, and it's gonna snap onto there. So now there's a cylinder attached to your gearbox. So what you're going to do is you're going to use this new tool that you found, which only applies to shapes, by the way. You can't resize motors or gearboxes. You can only resize the shapes here. And if you click this little S key here, it gives you this new option to start resizing these things. You can resize them up, down, outwards, whatever. So what you're going to do is you're going to compress this little cylinder into into an axle shape here, and make sure everything's symmetrical here. So like so. You're going to use the size tool to do that. And you're gonna pull it out just a bit, like so. And then you're going to click on the cylinder again, and use the movement tool to move it just to where it's touching the gearbox. We're going to move the gearbox in just a little bit. So now you have your drive axles. These are what the wheels are going to be mounted to. Speaking of mounting the wheels, if you want to use the stock wheels, you're going to click on the Wheels tab, and you can use any of these down here, along with adding rims, such as these, and adding tires onto them, like these. But to start out, I would prefer using these Ampflow wheels. So I'll take the Ampflow 6-inch, center them on my little axle here, make sure everything's in line, and then I will move it in on my axle. So now I have a wheel on my axle. And just so we don't forget, let's click on our axle. Or, not yet. Let's go to Materials, then click on our axle, and we'll set it to Hardox 500. So, you may think that our drive system is done. It is not. So, as you can see, the motors and transmission system is lined with a kind of red outline. That means it is not properly attached to the robot. So what you're going to need to do is you're going to need to go to Shapes in the Weapons tab and pull out a cube. And I still have everything mirrored, by the way, because these are both sides of the drive. You're gonna take out this cube and you're gonna place it down. You're gonna kind of use the sizing tool to kind of shape it down to look like a mounting or a brace, and you're gonna move it over the transmission, and you're gonna use this little duplication key, square to square, up top, and add another square, and move it over the motor. And then you are going to go into Materials and click on the squares and set them to a material. And while we're here, I would like to point out a really cool feature as well. If you want, say, these mountings to be the same color as your base plate, you can click on the mountings, go to Tint, and click Copy from Other, and hover over your base plate, and click. You can do this with any shape on the robot that is a default shape, a custom shape, anything that can be colored. Like, for example, wheels can be colored and motors can be covered, but these shapes can be colored. So if I wanted these to be the same orange, I could click on Copy from Other, and then click on this shape. And say I wanted these axles to be titanium. So I'm going to set them to titanium real quick. And I'd say I want to set these to titanium as well. You can do the same thing that you did with the color with the Copy from Other tool. So I can set this to titanium if I click Copy from Other and then click on my axle. Alright. So that's just a neat little feature that we can put in there. Let's move this out to where it's touching both the axle and the gearbox. So now your drive is mounted, and to make sure that it is mounted, you can go out to the Test In area, and you can click Flip Robot, and it'll throw your robot around, and if your wheels don't come off, that means they're properly mounted. Well, mine fell off because, well, there's a thing called arena damage, which we'll get into later. But my wheels are mounted correctly. What the hell was that? So everything is mounted correctly on your robot. Everything is attached. You're good to go. But your robot doesn't move yet. So we are going to work on making your robot move. So what we're going to do is we're going to go to the Electronics tab, click on ESCs. We're going to disable mirror for this, and then click on the 160 amp dual motor ESC, and we're going to move it right here. This will allow you to basically move your motors. It's an electronic speed controller. But it can't do anything without power. So you're probably sitting here asking, well, how much power do these things need? And if I go into power, you can see that there's a lot of batteries. Now this might seem very daunting, but trust me, it's really not. So if you go into the controls tab over here, and you can use the middle mouse to pan around this little grid here, and you click on the amp flow 828-400s, you can see what voltage they take and what current they take. So these amp flows take 36 volts. So most people would assume we would go find a battery with 36 volts. Or for example, this one with 33. But these are very, very big batteries. So instead of doing that, we are going to take some 14, some LiPo 4S 14.8 volt Pro batteries, which are these right here. And we're going to enable mirror again. We're going to move them out to the front here. And we're going to place 2 for each side. That is much more streamlined and compact than using those big old chunky batteries. Now you can use those big old chunky batteries, they just take up a lot of weight and a lot of space in your robot. So now that your batteries are placed, you can now provide power to the ESC, which can be provided to the motor. But you still have no way of controlling the motors. So we're going to go to Electronics and click on the RC receiver and move it. Oh, let me disable mirror. Move it onto the robot like that. Move it around. Yeah, there we go. And as you can see, all of these things are still red, so we're going to mount those as well using the same tactic we used for the motors. Like that. So now, everything's mounted. So now you have your drive set up. But if you go out into here, and you're pressing buttons, and you're like, why is my robot moving? So, before you do this, you have to wire it up in the Controls tab. So let's click on there. And you can drag these around by simply clicking and holding on them. So I'm going to drag my batteries out over here. And we're going to take these amp flows, can move them down to the bottom, and move our dual ESC in the middle. So for these little nodes, to connect them, you hover over them until you see this little hexagon. You click, hold, and drag them out to the inputs. So these, on the ESCs, these out nodes go into the in nodes on the motors of your choice. And now we have the batteries. And you're probably sitting here wondering, well, Skokonut, how am I going to get 4 batteries into one port? That's the neat part. If we go to power, and we click on wiring splitters, you can get a 2-port battery hub, and it goes all the way up to 12. But for now, we're just going to use a 2-port. And we're going to move it onto the robot. Take our little thing here, one of our little braces, and anchor it down like everything else. And then we're going to go back to controls and move the 2-port battery hub up here. And you're also probably wondering, well, now there's only 2. How are you going to get 4 into there? So the reason I chose these 14-volt batteries is you can link them in series. So instead of 14.8 volts, the batteries combined will provide around the ballpark of 29 to 30. And you can do that by dragging the battery out node into the series battery thing here. And once that is done, you take the battery out node that you didn't connect, and you connect it to the in ports on the 2-port battery hub, like so. And then you link it up to your ESC. But you are not done yet. So first, let's make sure we know what direction your robot is headed. So let's go back to overview. This yellow arrow represents where the front of your robot is. You can change this on the robot. Say if for some reason you wanted to build your robot sideways, you could do that. Or if you accidentally built your robot backwards, you could simply flip the axis the other way. And it goes 360 degrees all the way around the robot. But for our intents and purposes, we'll just set it to 0 as it was before. So we know that we are looking from the back of the robot towards the front of the robot. So that means that this is the left motor, and this is the right motor. And you can see through the grid, as you click on the parts, they highlight. Like so. So we're going to take our RC receiver, and we're going to drag the number 1 node into channel 1, and the number 2 node into channel 2. So the number 1 node is going to flow into channel 1, and the channel 1 is going to flow into output 1, and the output 1 is going to flow into our left motor. The same is to be said with output 2 into channel 2, into output 2, and into the right motor. So now what we are going to do is we are going to click on the RC receiver, like so. And you can see this big old list that comes up. So what you're going to do is for channel 1, since this is the left motor, you are going to hover over the left motor button and click it. And now that motor is bound to left motor controls. And you're going to do the same with the second motor, but this time it will be the right motor. And now that that is done, your robot is going to drive backwards. Do not fret, you didn't do anything wrong. There's just one step that you will kind of have to take care of. So what you're going to do is you're going to hover over the amp flows, and you're going to click on them. And then you're going to go press reverse direction, like so. And if your motors are properly mirrored, it should automatically apply to the right motor as well. So now your robot drives properly. That is how you make a drive system. Now some little housekeeping things. These amp flows say they can only take 250 amps continuous. Right now this dual ESC is putting out 300 amps. To lower that to ensure your motors do not burn, you can click on the little thing here and click on these sliders. And and drag them down to 250. Another thing is, see these little keys that say center brake? So as you notice, once I stop moving, the robot comes to a dead halt. And that's because of the center brake. If I disable that, the robot will drift, because it's no longer trying to brake. I would personally keep center brake on for drive. It does have its purposes though, especially if you're balancing weapons, which I'll get into later. I know I'm saying I'm going to get into a lot of things later, and I'm not kidding. I'm going to get into a lot of things later. This is going to be a very big video. So, for right now, you have basic drive. And that's cool and all, but what you have basic drive, but you don't really have a robot. And you're probably sitting there and you're like, well, how do I fix that? How do I make this look like a robot? And it's actually relatively easy. So what we're going to do is we're going to click on the wheels and we're going to delete them. And we're also going to delete the axles. And we're going to resize these a bit just so they're not too massive. And then we're going to go to the motion tab, go to the transmission section, and click on chain transmission. And mount it to the gearbox stub. Oh, make sure you have mirrored on, by the way, because I just forgot to do that. Right, so chain transmission. Put it on the gearbox nub. And it looks like you just put a gear on there. It doesn't look like much. So what we're going to do is we're going to click on the gear. And we're going to use this gear size slider to make it a little smaller. And move it inwards on the little nub. So now you have what looks to be a gear wrapped in a chain. And you're probably sitting there, you're like, so what? This is not helping me. But the magic happens when you click on it and you start to move it. It's really cool. You can move this chain transmission all across the robot. And it will allow you to keep your motors in this place while still providing power to other areas of the robot. So I want my rear wheels to be here. We're going to make a four-wheel drive robot. Similar to something like Bite Force or Endgame. If you watch BattleBots, or if you watch Robot Wars, it would be more like shoot, all of those were like two-wheel drive flippers. I'm trying to think of a modern Robot Wars example. Hobgoblin, I guess. Hobgoblin, Frostbite, something like that. It's just four-wheel drive. So now you've got your rear-wheel drive. And you're probably sitting there and you're like, oh man, I really don't want to put more motors down, put the gearbox on, and then put another chain on. Well, you don't have to. So what you're going to do is you're going to click on the motor. And you're going to go and click on these double square to double square. Like so. And now the entire assembly has been copied and you can move it. So I'm going to show you something called stacked drive. So right now, two chains cannot run off a single motor. So to mimic this, we simply clip, we clip a second motor into the existing motor seamlessly, and we drag that second chain that came with it off in another direction to make it appear as if the motor is running either a continuous long chain or two separate chains. So we're going to place this entire assembly down here. We're going to rotate it. Oh, no, not like that. I'm gonna just for this, we're gonna shoot this little gearbox out here. I'm gonna move these around until they are perfectly clipped within the robot. So we're going to grab our chain again, and it went into the floor. You're probably like, oh no, now my chain's on the floor. Don't worry about it. If you press B, the work table goes away, and you just go get those. And we're going to drag these out over here. So now you have the basis for four-wheel drive. And you're probably wondering, well, are those motors, those new motors you just put in, you just clipped in, are they going to run off the same batteries? Yes and no. You're going to do the illusion of basically what you're doing with the motors, but you're going to do it with the components. So if I take the ESC, I'm going to copy the ESC, I'm going to turn off mirror real quick, and we're going to move it into the existing ESC to make it look like it's one ESC. You can only do component stacking like this with stacked drive. You can't do it if your motors are not stacked like this, because then your robot is going to be unrealistic. Alright, so now we have the components needed for four-wheel drive, except we just don't have the wheels yet. So what we're going to do is we're going to take some of these brake things here, and we're going to put them at the end of these chains, like so. And we're going to do the same thing with the front end, like so. And then we're going to do the same thing we did with the axles earlier. Mount some cylinders. And move them through the robot like this. And set those materials, the titanium. And instead of using the stock wheels like I showed you earlier, we're going to do a wheel tactic that is really, really, really cool. It allows your wheels to be more durable. Because the stock wheels, they tend to come off if they're hit once, which is not desirable if you're trying to fight other robots. So what you're going to do is you're going to go shapes. And you're going to scroll down until you see the quarter cylinder. And you're going to take this, move it over here, and rotate. And you can double check to make sure it's perfectly centered on 1/4 of your axle. As you can see, it is right there. I'm going to shrink this down. Make sure everything's symmetrical. You can check this, by the way, if things are symmetrical with this little thing here. It tells you the width, height, size, whatever, coordinates of where the parts are. Like, this looks like it could be symmetrical, but if you want to double check, you can open up this little side menu and see that it's not. So you can make it symmetrical. So let's shrink this down. Move it over here. So now you have one piece of a quarter cylinder wheel. So what you're going to do is you're going to take, you're going to go back to materials, going to click this little quarter cylinder here, and click rubber. And you can turn it whatever color you want. I just turn my wheels black. So now you have a part of your quarter cylinder wheel. So then what you're going to do is you're going to click on the wheel, click the copy button, move it on top of this little ridge here on the existing quarter cylinder, and rotate it until it appears as a half circle. And make sure everything is lined up, because sometimes it will not be lined up. So now we have a half circle. So what we're going to do next is we're going to click the first shape, click the double copy tool, and move it on top like this, and then line everything up. So now you have a quarter cylinder wheel. But this is just one slice. Typically, you're going to want more than one, especially because things fall off relatively easily. So if you click the root shape, which is this back quarter cylinder back here, and click the double copy tool, you can move it over the axle and use that root shape to properly center it. Make sure everything is okay. Yep. Nope. I don't want to do that. And simply do that again. And you can't clip the slices, but you can rest them up right up against each other like this. And just do the same thing. Over and over until the axle is filled. And make sure you're clicking on the root shape. You can tell if you're clicking on the root shape if the entirety of the wheel turns green. If a part of it is yellow, that means you're clicking on a part that is not the root shape, and you can mess up the part that you have. Another little dandy feature is so you don't accidentally delete an entire section of the robot, you cannot delete the root shape. You can only delete a part that has nothing attached to it, which is this piece right here, because it was technically the last one in the hierarchy to be added. Like, I can delete this one, but I can't delete this one, because this one's connected to it. I can delete this one, but I can't delete this one, because all of this is connected to it. So as long as the shape has nothing connected to it, it can be deleted. We're almost done with this front set of wheels. So now you've got your front wheels. And you're probably like, wow, that was really slow. I don't want to do that again. So I have a simple solution for that. Like what we did with the motors and copying the entire assembly, if you click on the axle, click on double copy, you can take the entire wheel and mount it on the rear chain. Simply move it in like so. So now you have four-wheel drive. It's looking a lot more like a robot now, not just a testing platform. Like, it's still looking like a testing platform by all means. It's very bare bones. But we can... Cosmetics is something that I probably won't cover here. A good friend of mine, Brickmaster, did a tutorial on basically how to make your robot look good. Right now, I'm just explaining the mechanics and proper mounting and what have you. So now we have our four-wheel drive base. Now this won't work right off the bat because you need to go back and wire things up again. And you can see these are kind of lighter now. That's because there's stuff inside them. Because when you stack components, their little nodes will stack on the component that they were basically... When you stack components in the game, they also stack in the control panel. So we're going to move these batteries out. So these are these two. Oh, I did forget to do something. I forgot to add these. Rare forgetful moment for me. It's aghast. I shouldn't even be teaching tutorials. Ugh. Ugh. One shudders to think. Actually, let's get rid of the... okay, so we'll get rid of the ones that were in the hierarchy. Okay, so I should explain what I'm doing. So I'm trying to get rid of the batteries that I placed down for this side so I can mirror them properly when I try to place them down again. So to try and get to those, if I click on, well, fuck you, RR2. I got it first try. But, so, the original battery is showing in yellow, but the battery I clicked on is obviously the stacked battery, so I can just get rid of that like this. But if that doesn't work first try, like say I click on this and it's green because it's the root battery, I can hold shift and arrow keys, and I can move around the robot in the order of parts I placed. So I'm going to move around until I get to the battery that I placed earlier, and I can delete it. Pretty cool, huh? It helps with robots that have a lot of shapes. So you're not having to tear things apart and dig into things and undo all your hard work. You can just shift and pan around with the left and right arrow keys. It's pretty cool. Alright, so now let's get these batteries properly stacked. Make sure they're mirrored, because everything is easier when it's mirrored. Alright, so now those batteries are properly mounted, and we can go back to the control panel and move those out. Now some of them will migrate to some spots sometimes, spots they're not supposed to migrate to, so just be mindful of where these things are. So we have all 4 of our stacked batteries. So what they need to do is they need to be set in correspondence. They basically need to be on the same side as the batteries they were stacked into. So like this battery cannot be on the right side because it was stacked with the left side batteries. So all of the left side batteries are going to go over here. The right side batteries are going to make their home right over here. I'm going to take the secondary ESC, like so. Move out the amp flows. And we're going to take a... We're gonna stack these another battery splitter, because you have to stack all your components when you're doing stack drive. So now everything is ready. So we'll link it up like we linked up everything else. Alright, so now you have a 4-wheel drive robot. Did those not weld correctly? Okay, so my wheels didn't weld correctly. This is a problem. So what we're going to do is we're going to take the chains and we're going to move them in very slightly. And we are also going to create a secondary axle that is going to go in the center of the chain. That should work. It doesn't have to be terribly long, it just has to be there. That should work. Okay. So that worked. Okay, I think my drive is like fighting against itself. Let me make sure I did everything correct. See, even veterans like myself, that we also make mistakes, so. Lift motor for 3. Why is my drive fighting itself? Sorry guys, I'm just trying to figure out why it's fighting itself. Because it shouldn't be doing that. Okay, so left motor for 1 and 3. Oh, it's because I enabled limits. There we go. Okay, so I accidentally enabled limits, which we'll get into that later. But now you have 4-wheel drive. So now your robot is significantly faster than it was before, as you can see. It's pretty cool. So another thing you're going to want to watch out for is your gearing. So if you click on the gearbox, you can set these to different ratios. Like if I want my robot to be faster, I'm going to go to a 3-to-1 gear ratio, and it's going to have a lot more speed. But that also consumes a lot more amp hours and puts a lot of stress on the motors. And it can cause them to burn out. As you can see in the telemetry, these motors, these amp hours remaining, this is how much time you have left. And the temperature, that's how hot your motors are getting. So as you can see, me driving this fast is bumping them up to 115, 117, 119. That's and still going up. That's not exactly great. So instead, we're going to set it to 1 to 1.5. This results in a slower robot, but it puts less stress on the motors, and it gives you more torque. Like, the torquiest config you can make is a 10 to 0.1 build. And as you will see, it moves really slow. But if we get the crate in here, which is the weight of a regular heavyweight robot, well, I was going to demonstrate the robot pushing it, but whatever. But anyways, this is the torquiest setup. Yeah, there we go. See, it's pushing in the crate. But it is really slow. And I guess you could really, if you wanted to, you could achieve the opposite. But this will also make your motors struggle, because sometimes you will be trying to achieve speeds that you just can't. And the motors will really start to struggle, and they will burn really fast. So the ideal thing that I would say for a just moderate whatever build is probably, I'd say probably maybe a 10 to 0.3. Let me see. No, that's not right. Sorry, I think it's a 10 to whoa, what the hell? Oh yeah, make sure you're doing both sides if you're doing 4-wheel drive, stack drive. Yeah, 10 to 3 is good for speed. 10 to 1 is also really good. It's kind of it's slower, but it's a little more torquey. But you can really play around with all the gearings and find out which ones you like. Let's talk about some of the things in here that I have not talked about yet. And then we'll get into different weapon systems, and I'll bring up some of the stock bots, and we can look at those. Let me see, what have I not talked about? Okay, so different types of motors. So different types of motors are going to require different types of ESCs. So the A2400s, those are brushed motors. So they're going to require brushed ESCs, which are these things down here, and they could just be found in the regular ESC tab. Brushless ESCs are specifically for brushless motors, and brushless motors cannot take brushed ESCs, just like brushed motors cannot take brushless ESCs. There's a lot of variety here for different things you want. Like you got little motors for little robots. You got kind of moderately sized motors for drive, like these. You got big motors for big spinners. You really can have anything you want. Pneumatics. We'll get into those when we start looking at the stock bots. But I'll go over everything you can find in the tabs. So electronics, you can find receivers, ESCs, brushless ESCs, gas valves, and wiring splitters. In power, you can find batteries, tanks, wiring splitters. In motion, you can find motors, brushless motors, pneumatics, transmissions, wiring splitters. In wheels, you can find the stock wheels, the tires, and the rims for the tires. For weapons, you can find piercing style weapons, such as this drill cone, spinning style weapons, such as this little horizontal spinner here, or vertical, you can mount it whatever way. Weapons, miscellaneous, you can get some flamethrowers in here if you want to get some like free shipping action in here, or a scoop if you just want to do a plain scoop. Shapes are also in here, and there are a lot of shapes, stuff like tetrahedrons, quarter cylinders, boxes with round holes. You really have anything that you could ever want in here. It allows you to build custom weapons, custom body shapes, whatever. And custom shapes basically advances on that. In fact, I'll show you how to do a custom shape real quick. So if you click on this little plus here, you can go into here, and there's a grid. And it works a lot like the chassis tool, with this being the center. And you can make whatever wacky shape you want, and you can make it. Now, say if you want the top layer to look a little different than the bottom layer, you can drag these around on the grid, and they'll stretch. So I've made what kind of looks like a rock here. And there's also a little side menu to disable snap when you're plotting points, or if you want the thing to be smooth, which is kind of strange, or the scale factor if you want to size it up or down. And you can apply different layers too if you want to, say, a third layer and play around with that or whatever. But that's really cool. And you can also resort your little tabs with this little button. You can sort them from A to Z, Z to A, weight or size. So let's go on to extras. Extras, you can add basically just little decoration pieces. These are really kind of optional, except for the extras miscellaneous, where you can have hinges for, say, forks or something, which I will get into forks later. So that is basically a basic rundown of Bot Lab, and everything you need to know for movement, creating a basic drive system, and whatever. The rest of the stuff I can show you without having to build a new robot. That's why I had all of my robots in here, and I'm actually going to I'm going to pull in the rest of the stock robots. Well, maybe not Honk. Well, Honk's good for, I guess, hammers or whatever. To aspiring new builders, don't take inspiration from Honk. Take inspiration from Launch Control and Jagged and Deuteranopia. The only reason I don't say Jesus is because Jesus is a little outdated. But whatever. So we're going to look at a vertical spinner weapon first. So we're going to bring up Deuteranopia here. Nope, I didn't want to make a new robot. My bad. So Deuteranopia. This is Deuteranopia. And as you can see, it is a vertical spinner. So what's going on here is what you're probably asking. And that's a good question, honestly, because a lot of people are going to see this, and they see all the parts, and be all pretty, and be like, whoa, that's super intimidating. And I don't know if I can make that. It's really simple, actually. So if I bring up one of my vertical spinners, We'll bring up a bomb out here. The bomb out's a, well, actually no, we'll get into bomb out later because bomb out has a little, it has a special vertical spinner. We'll do I Love Lean. So I Love Lean's weapon setup is very, very simple. It is just, and if you want to see another robot, you can go into the other tabs. You can click T chassis and T shapes, and you can see another robot. So as you can see, there is a motor in here, which is attached to a gearbox, which is attached to a belt, similar to how we did the drive. Just this time, it is positioned into a way where it is powering a vertical spinner. So you can see the belt come out and into this little triangle piece here. This is a vertical spinner mount. These are vital for if you want to build a vertical spinner. They usually attach to the main frame rails, which are kind of these right here. And they come up and they support the shaft where the vertical spinner is located. It's basically you need these so your vertical spinner isn't falling out. But they also need to look realistic. They can't just be like a stick. They have to look something like this. Something like what Deuteranopia had. This kind of triangle shape, or maybe a box, or something that has structural support to it. That looks like it can hold this weapon in place while it spins. Like if it was just like one of these holding up the weapon, that wouldn't be good. You're gonna need something that looks viable. I would ask to take inspiration from robots such as Bite Force in game, like I mentioned earlier, and look at how they construct their weapons. So while we're on the topic of vertical spinners, this robot uses a dual purple cat. These are excellent motors for vertical spinners. They are excellent. They're actually really excellent motors for any sort of spinning weapon. There are various other types of motors you can use. But I personally use the dual purple cats. They are big and they do take up a fair amount of weight, but they are worth it, and they will power pretty much anything you throw at them that isn't like massive. Like this is a fair-sized weapon. This is around probably 30 kilograms, and it powers this just fine. It's really a great little motor, but it is a dual motor, and that means it requires 2 ESCs, as you can see right here, that go into the motor. And there are a bunch of types of kind of cluster motors, like the ones I showed earlier, the Ampflo A28-400s. Those are just single motors. But then we have like the A28-150 duals. These can be used for drive. Those are dual motors, so they require 2 ESCs. Or you can get really, really ridiculous, or you can get kind of ridiculous if you go into the brushless motors and you go find where are they? The Tri-Cats. So these are 3 of the Cat X 3360 motors, just in a little triangle configuration. They're good for small spinners. I will note, more motor does not mean more power. Well, it does, just type of motor really depends. The triple cat does not have more power than the dual purple cat, because the dual purple cats individually have more power than the individual cats. So two of them are more powerful than 3 of the green ones. And I should stop calling them purple cats. They're called the Cat X1020s. Or, sorry, no, they're not called the Cat X1020s. What the hell am I thinking? Those are the small motors. They are called the Cat 3100s. these are the purple cats. And these are the dual purple cats. They're pretty cool. But like I said, I use the dual 3100s for spinners, especially vertical spinners. Of course, you have all the proper mounting here. Make sure everything's good and sturdy, because this is a 30 kilogram weapon, and you can't be holding it in with little sticks and pins and whatever. You need to be holding it in with proper mounting. This is a 25 thick Hardox 500 shaft. This is overkill for the weapon I have. What I would recommend for a weapon of this weight is probably you can get away with a 7 thickness Hardox 500 shaft that looks about this visually thick. And these are 5 thickness Hardox 500. This is typically what you're gonna see on your 20-30 kilogram weapons. But as you start getting higher from there, you're going to use the thickness slider to make them heavier and thicker. More in the probably 7 to 8 range if you're ranging towards like a 35, 40 kilogram spinner. In 50 kilograms, you're definitely going to need 10 thickness Hardox. I'm going to say that right now. You're going to need 10 thickness Hardox for that to be legal in any of the Discord tournaments. But yeah, so this is just a basic vertical spinner. I highly encourage you to look at Deuteranopia, which is the stock bot, because that is a really good example of a vertical spinner. Especially with the whole get up here. Sorry, the whole get up here. And the thickness and and the proper whatever. Now this is very complex. Like there's fillets and stuff in here. Fillets are nice and they will add better structural support. They will make it look more visually supported. They will allow you to pass legality better. And they will actually add more weld points, which increases durability of parts in a kind of a mild way. So yeah, this is a really good example. I definitely encourage y'all to go look at this. So the next weapon type we're going to look at is an offset horizontal spinner, which I have one right over here, right over here. So this is basically the vertical spinner concept, just turned on its side. Instead of having supports that are sticking upward holding in a vert, they're sticking outward and holding in a large horizontal spinner. You can look inside and see that there is motor, gearbox, chain, weapon, all this stuff. Same principles, but just on a different axis. That's all you really need to know about building that. Little nitpicky things. I recommend having your wheels be closer towards the center of mass of the robot, because the further away they are, the worse the drive is going to be. So the closer the wheels are to the COM, the better drive you're going to get. That's just it, period. We're going to look at a different type of vertical spinner real quick. We're going to look at hub motors. So this is a hub motor. So that means there is no motor within the chassis coming up into a belt powering the weapon. The motor is inside the weapon, as you can see here. And what you do here is you take a motor, you put a gearbox on it, you put it in a shaft, and you build the weapon kind of around it. It's really cool. And with this, you are allowed to clip the gearbox into the motor to better represent how hub motors actually work in real life. It's really cool. Alright. So the next archetype I want to go over is the hammer. So where is Jagged? There's Jagged. Alright, so this is Jagged. Jagged has an electric hammer, which is basically a vertical spinner with the same supports and everything, but instead of being a spinner, it has limits and it's an axe. So the weapon that powers this is a pancakey tech. So on the hammer, it has enable limits involved, which allows it to end at a certain position, which allows it to end right here, and allows it to start back here. And you can control that using the single momentary, which is how the hammer works. Or, sorry, double momentary. I don't know why that's there. Okay, sorry. The double momentary can be used. So, like, for example, his is set to M and N. So, you can press M to fire the hammer forward, and N to bring it back. It's really cool. But yeah, it's basically a vertical spinner, but with added limits. And a completely different geometry, because you're building out in this large stick-style fashion. You're not trying to use it to punt anything or hit anything. You're bringing him forward an axe, like Terahertz or Beta. Let's talk about flippers. Flippers, yes, flippers. Flippers. There are different types of flippers, but the most commonly used one is probably going to be your pneumatic flippers, which have entire different setups. So this is launch control. This is a pneumatic flipper, and these have very, very interesting ways about being built. So they use gas tanks. And as you can see here, there are two 2.6 liter gas tanks leading into a gas splitter component. This gas splitter will flow into the buffer tank, and this buffer tank will flow into the pneumatic control valve. The pneumatic control valve will flow into the flipper system, and the flipper system will flow into the CO2 exhaust. And the channel can be set by connecting the receiver to the pneumatic control valve. The PSI can be tampered with on the buffer tank, and it can be increased and decreased depending on what power you want. If you want more power, the buffer tank's going to be bigger, and this thing's going to be higher. If you want less power, the buffer tank's going to be smaller, and this number is going to be lower. If you want more gas, there's either going to be more of these, or they're going to be bigger. The flipper systems, they function a lot like the hammers in that you have to set a start and end position for them to properly function. So like this one, the start position is all the way down closed, and the end position is going to be somewhere up in the air. So it can fire properly like that. Super cool. Alright, let me think of what I haven't talked about yet. Forks, yes. Okay, so forks. Forks are a very finicky concept, because they can be done in multiple different ways. Like, let's see. Jesus has a hinged plow, I think. Yes, Jesus has a hinged plow. So Jesus uses the basic hinge for its plow, and that's fine. You really don't need more than a basic hinge. And they can also, the hinges can be sprung, so they're not flopping around everywhere. Like, Jesus's is sprung, so it's not flopping around everywhere when it's being flipped around or anything. It's kind of pressed against the floor with that spring. Another way you can do forks in hinged parts of a robot is with in-20 motors. So I Love Lean uses that setup. So there are nope, that's not what I wanted. There are in-20s attached to the forks, and they are held in with large axle pillars. And then those in-20s are respectively hooked up to small ESCs and small batteries. Because this, when motors aren't hooked up to electric components, specifically batteries, they get really weird, and they start creating like a bunch of drag. It's kind of a weird bug, but so this is what you want to do. You want to get a small battery, and you want to get a small ESC, and you want to hook it up to the fork motors. And you can also use this to enable limits. You can't spring them like the hinges, but you can enable how far you want them to go up and how far you want them to go down. So they kind of like little floppy fingers. All right, let me think. What else? Oh, there's some bot lab things that didn't go over yet. Okay, so these are just some housekeeping things. So if you want to take a screenshot of your robot, you can click on green screen. You can change the color, and you can take a screenshot of the robot. Hell, you can even do a turntable and take a video if you want. The smartphones, that doesn't really matter. If you want to take a picture of it on the work table, you could just get rid of the forward arrow if you don't want that. Oh, snap. Okay. Snap is really, really, really important. I don't know how I forgot about that. So, snap is very, very, very finicky. It determines on what increments of space your part moves on. Like, I use .005. It's fine, but it's not too fine. But if you wanted to get really intensive, you could drop it down to .001. And that, like, it's still snap, but it looks like I'm smoothly moving it. You can do the same thing with rotation, and you can do the same thing with scaling. And if you don't want if you want to just disable it altogether, just click on the snap check, and you're free to move things smoothly. There is no snap for this. Show center of mass. This is where you can see that. So yeah, that's pretty cool. I think that's... Oh, you can go in the outside, and there are different crates for you to test against. There's a 15 kilogram, a 55 kilogram, and a 110 kilogram. And there's a ball you can push around. Some barrels you can knock over. There's also a... come on. So some bricks you can push into. If your bot gets stuck, you can just click the reset bot button, and it goes back to whence it was. And you can look at your telemetry for all your motors up here. This also works for pneumatics and everything else. Alright, let's get into the meat of the actual combat system. So right now I have my graphics on high. This is a very, very intensive game. I'm just going to let you know right now. This is a very, very intensive game. So I'm going to set my graphics to low. It's not going to look as good, but it's going to run better. So I'm going to take... So we're going to go into this little exhibition battle zone. And I'm going to click on a robot. On player 1, I'm going to choose a robot. We're going to choose... launch control. And then for the second robot, we're going to choose one of my robots, Wilt. And we're going to leave it on AI, which is this little computer-controlled symbol here. And you can change it from player to computer at the click of a button right down here. And if you want to enable telemetry, You can down here. And I believe there's a hotkey to be able to pull that up. You can turn off the countouts. You can decide if the countouts are going to be visible. And you can decide if the timer is going to be visible. You can also determine how long the match is going to be. And once you're ready with all those settings, click Battle. And there are 3 preset arenas that come with the game. RR2 Arena, RR2 Origin Arena, and RR2 UK. We're going to use RR2 Origin. So now we are in the arena, once we've clicked on that. And using the number keys, you can cycle between different camera angles. And once you're ready,
3, 2,
spacebar.
1, go.
And then you can begin fighting the robots. And they will respond to whatever binding control they have, depending on what player section you're in. Hooray. Now say you want to take a picture of like an action shot or something. What we're going to do is we're going to restart the fight real quick.
3, 2, 1, go.
So if I got under him, he's freaking out. I don't know why he's freaking out. Come here. Come here. Stop freaking out. Stop freaking out. Come back. I can press the escape key and click this little camera icon down here. And I can use right click to pan my camera around and WASD to move. And once I have a thing that looks right, we can do certain things. You can adjust zoom. You can move up and down with control and space. And you can hide the HUD with H. And once you've done that, you can take a screenshot with the Enter key. And that will go to your screenshot directory. Pretty cool, huh? And once you're ready to exit free cam, just simply press the X key. Alright, let's get into the settings. So these are all the settings. You can set your resolution, graphics quality, the weld hint, which is the little red outline, full screen, and an experimental virtual reality mode that I haven't tried yet. I really need to try that because I have a headset. Audio, you can adjust the master volume, sound effects volume, and the music volume. I don't think this really applies anymore, the music volume, because none of the arenas contain music anymore. These are your controls. You can edit them. And there can be up to 6 cameras in an arena, which are correspondent to the 6 cameras on the 6 buttons on your keyboard. You can edit controls for the different players. Like player 1 can be WASD, space NM comma, and player 2 can be arrows ZXCV. Player 3 can be YJG, and whatever you want it to be. And you can also sync it up to a controller, which is very, very cool. I think I have... Okay. I kind of busted something for a minute there, sorry. Damage. So, arm damage and arena damage are very experimental. Arm damage allows things like hammers and flippers to do damage to robots. But it's very experimental and can cause a lot of bugs. Arena damage as well, it allows the arena to damage the robot, say with kill saws or screws. But it's very experimental. And damage multiplier determines how much damage spinning weapons do to other robots. And you can change it with this little slider here, which 200 is the max and 0 doesn't turns off the damage. Physics. Spinner impulse. This controls how hard the spinners hit. So you can crank it up to 200% and they can send things flying, or they can hit like wet paper towels. It's your choice, really. Physics ticks per second, it's basic physics ticks. Determines how fast the physics engine runs, and how quickly it responds to interactions. It's typically kept on 300. I wouldn't recommend messing with this unless you have like a NASA computer. Uh, especially if you're increasing it, because it gets really, really weird. Of course, you got the credits. I don't know where this went. Maybe they'll show up. Maybe they'll show up out here. There we go. Yeah, credits. All of our friends on the Robot Rumble 2 team. I'm not on here because I'm not a dev, but all those guys are really cool, and they have all the social links down here that you can use. What else do I want to talk about? I think that's gonna be all for now. Because I just give a quick rundown of everything. I might do a more extensive tutorials on each of the weapon archetypes in the future, and importing and exporting robots. But my voice is getting really tired because I've been recording for probably a little over an hour now. So yeah, I am going to end this here. Thank you so much for watching. If you have any questions, feel free to pop a comment down below, send me a message via Discord, send any of the devs or other moderators a message via Discord on anything. Use the support tab in the server. This is a very complex game, but it's very fun once you get the hang of it. So with all that said, this is Spaghetti Coconut, signing off.